Hi guys, in this video we're going to be learning about how to balance an equation. So first off, I just want to start by giving us a few points or concepts that we need to know. So first, chemical reactions are represented by chemical equations which identify both reactants and products in the actual reaction, and the reactants are on the left and the products are on the right of the arrow. Second thing is that in a balanced equation, there are the same number of atoms of a given element on both sides. So this is due to the law of conservation of matter, which essentially says matter cannot be created nor destroyed. So that should make sense. If we're not creating new atoms and we're not destroying any, the number of atoms on both sides of our arrow or our reaction should be the same. And if they're not, then we call the equation an unbalanced equation. And the ultimate goal of balancing is to end up with a chemical equation in which there are the same number of atoms on each element on both sides, because in chemistry we use balanced equations for most of our problems to solve for things, so we balance equations a lot. So in order to learn how to balance an equation, it's easiest if we go through the steps of balancing through an actual problem. So here's our problem. The reactants are two liquids, hydrazine and dinitrogen tetraoxide, whose molecular formulas are N2H4 and N2O4 respectively. The products of the reaction are gaseous nitrogen, N2, and water vapor. So now that we have our example problem, let's start off with step one of balancing an equation. And this first step is to pretty much write like a skeleton of the equation where the formulas of the reactants are on the left and the products are on the right. And with this, we use subscripts to try to neutralize and to create our compounds for our reactants and our products. So the skeleton for this problem, we would let's start with our reactants. So we see in our problem it says the reactants are hydrazine and dinitrogen tetraoxide, and then later they tell us the actual formulas of N2H4 and N2O4. So I wrote that down here in red to the left of the arrow. And now our products, they told us in the problem, are nitrogen and water vapor. So we can write that to the right, which I did here in yellow. And it's important to note once again that the subscripts in the problem are used to make everything neutral or without a charge. So now let's move on to step two, now that we have our basic skeleton of the reaction. So here's our skeleton, and step two is to indicate the physical state of each reactant and product after the formula by writing either in little parentheses a G, an L, an S, or an AQ. So a G is for if it's a gas, L is if it's a pure liquid, S is for it's a solid, and AQ is if it's an ion or molecule in water. It's in a water solution, so that's what we call aqueous. So in our problem, it actually tells us the states. It says the reactants are two liquids, and the products, nitrogen is a gas, and then it says water vapor, and we know water vapor is a gas. So we can then fill in our physical states after the formula, like it said to do in the step, and that is step two. So now let's look at step 3. And step 3 says balance the equation and use coefficients to uphold the law of conservation of matter. So we're going to use coefficients to change the number of atoms on either the reactant side or the product side in order to make both sides equal. So it's really important here that you're not changing the subscripts, but you are actually changing the coefficients. So let's just fix, this should be a H4. Okay. So now that we know that in step 3 we have to balance it, let's go through and balance it step by step. Okay, let's get rid of that. And so here's our skeleton equation with our states, which were step 1 and 2. So now let's start off by looking at how to balance this. So it's always really helpful that you start off by balancing by starting with an element that appears in only one of like the compounds on both sides. So like for example in this problem, oxygen appears once here and then once here. So it appears on both sides of the arrow, but it only appears once. And then same for hydrogen. It appears on both sides, but it only appears once. So those would be good elements to start with to try to balance. Unlike nitrogen, we can see that nitrogen is here twice on the reactant side, and it's here once on the product side. So we want to save that for last because those are not as simple to deal with. So that being said, let's start working with the oxygen first. So we can see that the oxygens on the reactant side, there's 4 oxygens as indicated by the subscript. And then on the product side, there's only 1 oxygen. So we need that 4 and 1 to both be the same number. So we need the product side to have 4 oxygens. So we do this by changing the coefficient in front of H2O. So we can then write a 4 in front of H2O because that would make 4 oxygens. And then we have 4 here, and then we have 4 here. So that is now good. We have the same number on both sides. So now let's look at the hydrogens. So we can see that there are 4 hydrogens on the reactant side, and on the product side we have to look at now both a coefficient and a subscript to determine how many hydrogens we have. So we do 4 times 2, and that equals 8. So we have 8 hydrogens because we have 2 in the subscript, and then we multiply it by 4, which is the coefficient, and that gets us 8. So once again, the 4 hydrogens on the left do not equal the 8 hydrogens on the right. So we need those to equal each other. So we can change the coefficient in front of N2H4 in order to achieve this. So we can write 2N2H4 plus N2O4 yields N2 plus 4H2O, because now the 2 times 4 gets us 8 on this side, and then 4 times 2 gets us 8 on the right side. So now we're good with the oxygen, we're good with the hydrogen. So now let's look at the nitrogen. So we can see here that the nitrogen on the reactant side, we have, in the first compound, we have 2 as the coefficient, we have 2 as a subscript, so we do 2 times 2. And then the next compound, we have 2 nitrogen, so we do 2 times 2 plus 2. And that is going to get us 6. And then we have 2 nitrogens on the product side as indicated by the subscript. So we then know that we need to get 6 and 2 to equal each other, and we can do this by putting a coefficient in front of N2, and if we put a 3 in front of N2, we do 3 times 2, and that gets us 6 nitrogens. So then those would equal, so we can write a coefficient of 3 in front of the N2. So the last step we just did will give us 2N2H4 liquid plus N2O4 liquid yields 3N2 gas plus 4H2O gas. So we know that we've hit the end of balancing an equation when we can go through and the atoms of each element equal on both sides. So let's make sure we can do that here before we move on. So we have 4 nitrogen here, 2, so that another 2 here. So that gets us 6 nitrogen on the left, and then we have 3 times 2 is 6 nitrogen on the right, so we're good with nitrogen. Now, if we look at hydrogen, we have 2 times 4, we have 8 hydrogens on the reactants, and then we have 4 times 2 again. We have 8 on the product side, so we're good with hydrogen. And now let's look at oxygen. We have 4 on the reactant side, and then we have 4 on the product side. So we have finished balancing this equation because we know that the atoms on both sides equal each other, and this is our final balanced equation. And don't forget to write the states because that will get you points taken off if you don't have them. And just some key points when you balance an equation. You're always, in order to balance it in like that third step that we just did, you're using the coefficients to change the number of atoms on both sides to fit the law of conservation of matter. You're never using the subscripts to balance it. The subscripts are only used to make the compounds neutral in the very beginning when you write it out for the first time. And another point is that there are an infinite amount of balanced equations that can be written for any reaction. So there are a lot of different ways you can balance an equation. As long as the atoms on both sides equal, you're good to go. And you might not get it like the first time you try to balance it, so you might have to try different combinations. Or if you start with trying to work with your oxygen first and you're having a hard time, put oxygen to the side and then move on to like a hydrogen, and you have to just always be ready to solve like the reaction or like in a puzzle. So you might not use one puzzle piece in the beginning right away, or you might have to put one to the side, but then you're going to bring them back in to form your overall like balanced equation. So I hope this video helped. If you need practice problems, in the chem modeling folder there are a lot of worksheets, and the more you practice balancing, the easier it becomes. So hope you enjoyed this video.